So I would definitely have your standard form notes that we did last class. I would probably have those right next to you so that way we can kind of get through these notes over Intercept and Vertex form. We're going to create a cheat sheet in this packet, so I want to make sure that you have the items from standard form so that way you can copy them into your cheat sheet in a bit. So you're not going to do it right at this moment, but we will create kind of a cheat sheet for you to help you with studying for your tests and quizzes. Okay, so let's first talk about the first page, front and back, which is the intercept form. So for intercept form, I'm just going to go through two examples. Intercept form literally takes the two factors, or the two roots technically, and it creates an equation for it. So this is how your intercept form equation will look. I'm going to kind of draw an arrow. It's going to be y equals a, x minus p, and x minus q. In this equation, the p and q are your roots. So the p and the q are your roots. If you think back to last class when we were talking about standard form, I'm going to kind of flip back and forth. When we were looking at standard form, the very first thing we talked about was the axis of symmetry formula here. With that axis of symmetry, what does that do to your graph? Not necessarily just, well, it does help with finding the vertex, but what does the axis of symmetry itself do, Desiree? Okay, it splits it in half, just any half, or two equal parts? Two equal parts. Symmetry means you're going to cut something in half and to create two equal pieces. So that's exactly what it means. The great thing about intercept form, which is this formula I've just given you guys, you can have an axis of symmetry as well. So I'm going to write out my formula for with my pen, the axis of symmetry. It's not going to be the same as negative b over 2a from standard form. It's going to now be p plus q over 2. I will tell you guys, because I already know somebody's probably not paying attention, the p and the q, don't just take them from the original formulas. I want you to actually solve for your x-intercepts first, then plug it into your axis of symmetry. So we're going to do that with example 1. So this is probably the basics that you need right now. Let's look at example 1. So in example 1, this one is first asking you to identify the max and min, and then we'll move on with the other things. So I'm going to write this on top really quickly. A, x minus p times x minus q. Okay, so first let's identify the a value. If you look at this equation, Nicholas, what's your a value going to be? Okay, there's not an a value, but we need to put something. What number should we put in front of this parentheses to compensate for that a? 1. Yes, bless you. You're going to have a equals 1. When that a value is equal to 1, Nicholas, what does that mean? Is your graph going to be a minimum or a maximum? Minimum, because it's greater than 0, which means it's going to open up. Next, it says axis of symmetry. That doesn't mean I want you to immediately find it, but I do need you to label it later on. Well, I just said this. In order to find the axis of symmetry, I want you guys to find the roots first, which are your x-intercepts. So my first real bit of work that I need to do is identify the roots, which is the same thing as your x-intercepts. Maria, how do I find the x-intercepts? What do I need to do? We did this last time. Plugging in 0 for y. Remember, f of x, guys, is the same thing as y. So we're going to have x minus 1 and x minus 5. By the zero product property, we're going to set both of the binomials equal to 0. So I'll add 1 to each side. And then I'll add 5 to each side. So my roots are going to be 1, 0 and 5, 0. Next, I did say that I can find my axis of symmetry from here. So let me scroll back up. Axis of symmetry. It takes the p and q values that you just found, and it asks you to divide them by 2. So a lot of students ask me, well, Ms. Tapia, which one's p and which one's q? My favorite answer is it doesn't matter. This can be your p value, this can be your q value, or if you want to be different, you can say this is your q and this is your p. I really don't care. You're just going to add the two numbers, whatever the x-intercepts are, and take half of it. So down here for step 2 in blue, we're going to find the axis of symmetry. Remember, AOS is axis of symmetry because Ms. Tapia is too lazy to write that out. So x is going to equal P plus Q divided by 2. Alex, what's 1 plus 5? And 6 divided by 2? So x is going to equal 3. What did you just find? It's the axis of symmetry. So over here to the side, x is going to equal 3. One last question, Alex. What is the axis of symmetry the same as? The x for the vertex is exactly it. It is the x coordinate for your vertex. So we did this last time. Once we found the axis of symmetry, we took that value and substituted it in for x for your vertex. So I'm going to rewrite this as 3, comma, some number. Omar, how do I find the y value for my vertex? To find y for the vertex, how do I find this value? What do I need to do? Not plug in 0. What did we just find? The x, the axis of symmetry, x value. Let's look back to what you guys did last time. Once we found that x value, we plugged it into our coordinate. And then what's all this information here? Okay, we're going to plug it in for the x value. So that's exactly what we did here, and we're going to do the same thing here. So what we're going to write, and I'm going to actually write this out in words, part 3 is to find the y value of your vertex. And the way we're going to do that is take that 3 that Omar and Alex just told us about, and we're going to plug it back into the original equation in black. So I'm going to recopy that original equation in black, and we're going to rewrite this as y equals, I always put parentheses around any number that I plug in, so take a second and look up to see what I'm plugging in. I put parentheses around all of the x's where they would usually be, and I'm going to substitute in a 3. I mentioned this last class, guys. Use PEMDAS to simplify order of operations. P represents any parentheses, any grouping kind of symbol. So, Michelle, what's the parentheses that we can simplify? Okay, so 3 minus 1 and then 3 minus 5. Now what? Okay, so what's 3 minus 1? And 3 minus 5? What's 2 times negative 2? Negative 4. We went through the parentheses. There were luckily no exponents. The last step was to multiply. I just lost my train of thought. Michelle, what did we just find? The y coordinate for my vertex. So up here, we're going to plug in a negative 4. There's one last thing I need to find, and that's the y-intercept. Caitlin, right? How do I find the y-intercept? The y-intercept. How did we do it last time? 4 for the x. So we're going to plug in 0 for the x in the original equation, and we're going to solve. So I'm going to do that work over here in this corner. For my y-intercept, we're going to plug in 0 for x, and we're going to solve. We're still using PEMDAS, guys. A lot of students will tell me, oh, Ms. Tapia, I have to distribute. No, don't distribute anything. Please don't. Just use PEMDAS. So y is going to equal, in the parentheses, we're going to do 0 minus 1 and 0 minus 5. There's no exponent. I will need to multiply negative 1 times negative 5, which is just 5. We just found the y-intercept. We've graphed this literally before. So what I need you guys to do, take the space that's next to it where the graph is and start graphing it. Plot your points, draw your axis of symmetry, all that stuff. I'm giving you a little bit of a head start. Graph this out. I have 4 points on my graph. As you guys probably remember from last night's homework, you're probably going to need to find at least 5 points. And that includes on your tests, quizzes. I'm more than likely going to ask for about 5 coordinates. I need to find at least one more point. What can I do? Go ahead.
You look at that top coordinate, which is 0, 5, and then you see how many spaces away it is from the axis of symmetry, and then you will plot a point on the same distance away on the other side.
That's exactly it. So we're using the y-intercept, and it won't always be the y-intercept, but it more than likely will for most cases. So we're going to take that y-intercept, and like Desiree said, we're going to count how far it is from the axis of symmetry, and we're going to go the same distance on the other side to create an equal point. Remember, since it is going to the axis of symmetry, it creates 2 equal parts to your graph. So it's going to be somewhere around here. Once you have those points, go ahead and complete it with a curve. Mine is going to be a shaky curve because I'm on my iPad, but it should work. All right, all I need to find now is the domain, range, and end behavior. So Brooks, what's the domain for this? Read it from left to right. No, it's not just the numbers. And what's another way to write negative infinity to positive? Guys, for all of your parabolas, unless I give you endpoints, it should always be all real numbers for every single domain. Brooks, what's the range? Go from the bottom of the graph to the top. And at -4, what type of circle do you have? So we're going to put a bracket. The last part is end behavior, Brooks. So as x approaches positive infinity, so as these x values keep getting bigger, what's happening to this curve? Where is it going? Where's this curve going? Up. And where's that up going to? Infinity. We said this, I think, last time, but if not, I'll say it again. With your end behavior, since it's a parabola, both ends go in the same direction. They're either both going up or they're both going down. So if you get as x approaches positive infinity, f of x, which is y, also approaches positive infinity, that means that this value for f of x for the second part should be the exact same. So as x approaches negative infinity, so as the x's go this way, this curve is going to continue to go up, which means those values are going to get closer to positive infinity. That should be the same for both. All right. You guys, flip it over to example 3. I want you guys to do it. It's on the back of this page. Before you guys do anything, I'm going to write on top of this y equals a, x minus p, x minus q. The a value for this is what? And what does that -2 mean? It's less than 0, so it's going to be a maximum or a minimum? Maximum. This is a maximum, which means it's going to open where? Yep. All right, I'm going to give y'all about a minute head start. You're doing the same process we just did on the last page, so if you need to flip back and forth, you can. I'm just checking in really quick. You should have definitely found your roots by now. You should have found your axis of symmetry as well, which was x equals -2. Make sure when you write your axis of symmetry, it needs to be an equation. I'm not putting that x equals for decoration. It's not for fun. X equals -2 is an equation for your axis of symmetry. Anytime I ask for the axis of symmetry, I want an equation. So as of now, if you haven't gotten to this point, or if you have, you should be almost done with the vertex, which is the next thing we're going to find. We take that axis of symmetry and we plug it in for the x coordinate for your vertex. So I'm going to leave you alone for a bit. Find that y coordinate for your vertex. That's your next step. And then, of course, find your y-intercept. The steps that we did last class on standard form can help you with solving this. It'll tell you what to plug in and for what. Okay, so I've filled in kind of the last couple things that I need. Let me write my y-intercept over here. I found the y-coordinate for my vertex, which should be positive 2. And I found my y-coordinate for the y-intercept. So when x is 0, plug that in this little space that I had to squeeze in. Our y-intercept was negative 6. So from here, you should have been able to graph this out completely. Is there any issues with any of the numbers or any of the coordinates that I found? All right, cool. So over here, I'm going to graph out where negative 2 is first. I'm going to plot negative 2, positive 2. I had 2 roots, which are your x-intercepts, and I had 1 y-intercept, which is going to be reflected across the x-axis, or excuse me, y-axis. Why do I keep saying that? That's your axis of symmetry to create this curve. So I reflected the y-intercept across that curve. All right, all I need to know now is the domain, the range, and the end behavior. So, Mia, what's the domain for this? But the graph's opening down. It's still on the x-axis. Both of these arrows are still going to be going to the left. It's going to continue to go to the left, so that's why it's going from negative infinity to positive infinity, because this arrow is going to keep going down. It's going to keep hitting every single x value on that x-axis. Mia, what's the range for this? This one's different. What kind of 2? Positive or negative? Positive, yes. And then you do put a bracket around that. Perfect. Since this graph is flipped, your bottom of the graph is going to start from negative infinity, and you're going to end at this top part on the y-axis. So that's why I purposely asked Mia if it was going to be a positive or negative 2, because some students will say, oh, Ms. Type, it's going to stop at negative 2 because that's the x-coordinate. I don't care about that x-coordinate. When you're looking for the range, you're looking for that y-coordinate on the y-axis. And then last one, remember, for the end behavior, as x approaches positive and negative infinity, the ends of that gray curve should be going in the same direction. So Mia, what direction are they going in? Negative infinity for both. Both of them are going down. All right, give me some nods or shakes. Is this okay with intercept form? All right, cool. Let's look at the next page, example 1. Let's talk about vertex. If I'm moving too fast, guys, please tell me. Vertex form. Look back at your notes from standard form. I'll give you a hint. It's probably on the last page of notes that we covered for this packet. What's the equation for vertex form? What's the equation? Chris, what were you saying? Not A. X. There you go. X minus H. Not square root. That's squared. You're fine. Squared. That's your vertex form. We talked about it last time. You should have seen this formula back when you were in Algebra 1. Thank you, Chris. From this form, it's actually one of my favorites because you have to do significantly less work than the past 2 forms that we've been talking about. So the first part asks you to identify the vertex. So the vertex is a point, it's a coordinate, and that coordinate is going to come from this h and this k value. Both of those are going to tell you your, let me try that again. Both of those variables, the h and the k, h goes first, that's going to be your vertex. So the h first, then the k. I will also make a note here. I always used to tell my students, I still do, in first part of the cycle, for cycle 1, I always tell my students, whatever sign is in here, you do the opposite, because it's next to your ex-boyfriend or girlfriend who's always lying. So for the h value, right now some students will tell me, oh, Ms. Tapia, this is negative. Whatever sign is in here, you're going to do the opposite when you pull it out. So you're going to have, instead of a negative h, you're going to have positive h. Same thing here. If it was a positive h inside, you would pull out here a negative h. Just do the opposite sign. The k is my favorite. That's like your new boyfriend, girlfriend who's always going to tell you the truth. So you don't have to worry about that sign. It's going to be the exact sign that you see it. The equation for your axis of symmetry is going to be x equals the x coordinate for your vertex, which in this case is h. And then the last part is let blank for the y-intercept. Well, in order to find the y-intercept, you need to have x equal to 0. So for this question, I'm going to do number 1 with you guys, and then you guys are going to do one of the other questions I pick. So for question 1, let's start out simple. First thing I want to do is I actually want to write on top y equals a, x minus h squared plus k. And I want you guys to help me identify a few pieces. So for my first thing I need to identify, and usually I do this for every vertex form problem I have, I immediately label the a, h, and k, because h and k are going to do a couple things on this problem. Okay, so Michelle, what's the a value? What's the h? -2. Take out the opposite sign. That's next to ex-boyfriend, girlfriend. And what about k? +2. So, Michelle, what's the a value again? And that negative means what type of min or max? Which one? Max. It's going to open down. Next, I need to write the axis of symmetry. Mia, what did we say the axis of symmetry was? X equals h, which is what number in this case? -2. And then the last part, Michelle, what's the vertex? Give me the coordinate for this problem. Perfect. That's why I say label out all of those things first so you don't have to worry about it later. Okay, my next item that I need to find is the y-intercept. So we talked about this last class. We talked about it earlier. To find your y-intercept, and we even wrote it up here, plug in 0 for x and you're going to solve. So y is going to equal -2 times 0 plus 2 squared plus 2. Definitely use PEMDAS. Please use order of operations. Andrea, inside the parentheses, what are you going to do? What's 0 plus 2? P is done. E stands for exponents. So I see that exponent of 2. What am I going to raise to the second power, Andrea? +2. So you're going to make this -2 stays there. What's 2 squared? 4. We're now going to multiply and divide. Is there anything to multiply or divide? And what's -2 times 4? And then the last part is to add and subtract. So I have -8 plus 2, which is what, Andrea? Yep. And what did we just find? Our y-intercept. Especially if you one day plan on taking a class like AP Statistics, you want to make sure you not only can find an answer, but you can say what exactly that means. How does it relate to your problem? Okay, thank you, Andrea. Mia, I'm going to come back to you. How do I find the roots for this? How would I find the roots for this equation? What do I usually have to do to find the x-intercepts? Set y equal to 0. So let's do that. But how do I solve this? Not just Mia, all of you guys. Take a second and look back at the notes from last class. It was on the very last page, the last thing we did before we ended. It's already being squared though. So what method do I have to use? Square root both sides. Yes, it is being squared, but we're going to have to do the square root method. We need to isolate the x squared. See how there's methods to my madness? Everything connects. So we're going to have to do just like we did here. We're going to have to set the y equal to 0 like Mia told us, and we're going to have to solve. So Mia, go ahead and help me solve this. What's the first thing I need to do to isolate? Which 2? There's 3 of them.
Oh, the +2.
The +2 at the very end, that's what I'm going to move. Now what?
Divided by -2.
And I'm going to slow down just a bit because I know some people need some time to write. Now what, Mia?
Square root both.
Okay. And when you square root both sides, be careful. What's the square root of 1?
Plus or minus 1.
Plus or minus. Please don't forget that plus or minus, guys. Once you take that square root, you don't need the parentheses anymore, and you just have this. Carol, what does this mean if you have plus or minus 1 equals x plus 2? What are you going to have to do? I know I still need to isolate but how? Because that plus or minus means something. What does that mean? Brooks, help her out. Well, what do you mean plus or minus it? Because this plus and minus are two signs. Mm-hmm. I know you're talking about moving this over, but before we even do that, I need to figure out what to do with this. Alex, go ahead. We're going to make two equations. Whenever you see this plus or minus, guys, I'm actually going to highlight it. When you see that plus or minus, you have to split it. You have to split it into two, and I think that might be what some of y'all were getting at. So I'm going to put one equation as positive 1 equals x plus 2, and the other equation as negative 1 equals x plus 2. I want to make sure that when you solve it, you should get two separate answers. So, Carol, I'm coming back to you. How do I get x by itself now for that first equation on top? And that's going to give me negative 1 equals x, so that's one of the x-intercepts. And then I'll subtract the other one to make this negative 3 equals x. Those are your two x-intercepts. Don't make it more difficult on yourself, because I have a lot of students who say, oh, Ms. Tapia, at this point, I can FOIL this, and then I can distribute. That's way too much work. Don't do that. That's way too much work. Let me go ahead and write down my roots. Negative 1, 0, negative 3, 0, and you guys, I'm giving y'all a head start. Start graphing. It's not intentional, but this one has a lot of the same information as the last question. Again, it's not on purpose. It just so happened to work out that way. It won't happen like that on tests or quizzes unless I really don't pay attention to what I'm quizzing you guys on, but that shouldn't happen. So, Enya, if I was to label the domain for this, sorry, go ahead and finish your graph. If I was to label the domain for this, what would your domain be? All real numbers. What's the range? Start from the bottom of the graph. Where's the bottom of the graph going? Mm-hmm. And where's the top? 2. And that's a bracket. One last thing, Enya. As x approaches positive infinity, where's this curve going to? Yep, and that should be the same for both of them. Don't just automatically get lazy and write it for both. Double check it. As x approaches negative infinity, this curve does continue to go down towards negative infinity. All right, you guys are doing one last question before you create your cheat sheet. Flip it over to example 3 on the back side of this page. All the extra questions that I don't get to, y'all should know, is extra practice. So if you want to do those before a test or quiz, you're more than welcome to. Ew. Example 3 doesn't look like vertex form. Vertex form, like we've been doing, is y equals a, x minus h squared plus k. Okay, I see something is squared. I think this is a k value, but I don't see an a and I don't see an h. Okay, well, the a problem is really easy to solve. What's the coefficient in front of x squared? 1. Okay, so I can just put a little 1 there. I know the a value is going to be 1 now. But it's that h that I'm still missing. I need that parentheses. So I can rewrite this as y equals 1, x something squared minus 2. What can I put in parentheses here that won't affect this x squared? Go ahead, Alex. A 0. If you don't see a number in the parentheses to give you that h coordinate, you can make one. Just put in 0. Don't make up a number. Don't put 1 or 2 or 3. If you don't see a number in parentheses like this, put in a 0. And if you're like, Miss Tapia, can I put plus 0? Yeah, sure, you can. When you take out that number, it's still just going to be 0. 0 is not positive nor negative. All right, from here, I think you can solve it. So I'm going to give you about a minute head start, and then I'm going to start working through this one with you. I just want to check in really quick. Hopefully you guys agree I got a minimum. I got my axis of symmetry is x equals 0. If you just put a 0 there, guys, it needs to be x equals 0. Y'all know I'm petty. I will take off a point for not having that x equals. I know my vertex is 0, -2, but I have a question. Without me doing the work to find the y-intercept, what is this point? Graph it out. What is this point? Where's 0, -2 on your graph? It's a woo? No, what is it? Y'all are looking at me like I'm going to tell you where's 0 on this graph. Where's 0, -2? It's a y-intercept. It's right here. So what I'm trying to tell you is this work that I just did here was so unnecessary. I didn't have to do it. If you solve a question and you notice that the vertex is the same as your y-intercept, you don't have to solve mathematically for that y-intercept. You've already done it. So 0, -2 is technically what I found here, but it's also the same thing as your vertex. So in this case, your vertex is going to be the same as your y-intercept. Like while you guys are working, don't just do the work blindly and just say, oh, I'm just going to get it done. No, make sure you know what you're looking at so you don't have to do twice as much work. All right, finish finding the roots. When you guys, after I kind of unfreeze this, I'm going to show you guys what the roots should be and what your graph should look like. So yeah. So I'm pretty sure some of y'all have gotten to a little point right now where you're like, I don't know what to do. Okay, so you guys have your roots. Are you guys okay with the square root of 2 being my root? You can either use the new equation that you guys wrote, or you can use the original. Usually when I have you guys find something, I try to recommend you use the original function just because it's less messy than the parts where we've had to manipulate things. So for the roots, all I did was I just added 2 to the other side, as you can see here, and then I square rooted both sides. The issue is, what's the square root of 2 approximately? If I didn't give you a calculator on your test or quiz, I would expect you to know this. What's the square root of 2 approximately? What's the square root of 1? 1. Okay. I don't know the square root of 3. What's the square root of 4? 2. Square root of 2 is in between that, so it needs to be 1 and 2, or in between at least 1 and 2. On your graph, whenever you graph these out, I would literally, like I did here, just graph it out in between 1 and 2, which I need to actually correct. In between 1 and 2, so about here. The actual exact value for that is at 1.414. 1.414, technically 2. So that's technically the simplified radical for that. On tests and quizzes, guys, if I give you the square root of 2, don't look at me for a calculator. You can do this on your own. There's one last thing that I noticed before you guys finish. There's only 3 points total on this graph. There's nothing to reflect because your y-intercept was already the vertex. How can I get at least 1 more point for this? Some of you guys did this last class on your homework. How can I get at least 1 more point? Insert any x value you want. That's exactly it. I would recommend picking something that's close to your x-intercepts, for instance, something that's close to your last point that you graphed. So I would either use 2 or 3. I'm a little lazy, so the smaller the number is probably the one I'm going to pick. So let's just plug in x equals 2 into the original equation, and let's figure out what the y value is. If you can just find one other point, you're good. So let's use a point on the x-axis to find a y value on your graph. It's probably like obnoxious of me to write that much, but you'll be all right. So y is going to equal x squared minus 2. I said, after Mia suggested to pick any x value, let's just use 2. It's close to the x-intercept. It's not too big. So we're going to plug in that x equals 2 to try to find that y. So Zara, I'm going to plug in this 2. What's 2 squared? And what's 4 minus 2? So what do you think I'm going to do with that x and that y? Graph it. That's exactly it. You have a x equals 2, you have a y equals 2. Plot that point, and then reflect it across your axis of symmetry. Anytime I give you a point, or anytime you guys have homework questions like this where you only have 3 points, you can do this for any question you need to find another one. And then once you have that done, go ahead and curve this graph going up. Chris, what's the domain for this graph? There's two sides. All real numbers. There you go. Negative infinity to positive or all real numbers. What's the range, Chris? Not -3. What's this point down here? Look at your vertex. What's that y value? -2. All the way to where? Yep. And for your end behavior, as x approaches positive infinity, this curve is going to keep going up towards positive infinity. Same thing for as x approaches negative infinity, f of x will also approach infinity. So what I'm going to have you guys do now, which is technically going to be like your cheat sheet, is the next page. So on that next page, it says summary. That summary, I'm going to put in big words at the top, is your cheat sheet. Obviously, don't use this on my actual tests and quizzes, but this will help you with studying. So, study cheat sheet. Let me actually add that in so you guys don't complain. This is your study cheat sheet. I'm going to help you with filling out part 1. You guys are going to do 2 and 3. When you fill this out, guys, don't just say, okay, I need to copy exactly what Ms. Tapia puts. No, put what you want that will help you remember this information. So I would definitely have the notes that we did last class right next to you because I'm literally going to be asking for different pieces from this packet. So the first thing that I need to know is max or min. Nicholas, how do you know if you have a maximum or a minimum, or how can you find that if your equation is in standard form? Okay, so if you have an a value that's greater than 0, what does that mean? It's a minimum, which opens where? Yep. What if your a value is less than 0, Nicholas?
It'll be a maximum.
And where do maximums open? This max and min stuff is going to be the same for all 3 parts, for intercept form and vertex. So if you want to copy that down in a second, you can. Next question, axis of symmetry. Maria, how do you find the axis of symmetry for standard form? Look back at your notes from last time. No, I need it as an equation. That's it. Just like I said, if you don't give me that x equals, guys, I can't give you full credit. I think it was Omar who helped me with this earlier. When you're finding the y coordinate for your vertex, you always need to take the axis of symmetry, which is your x value. So I took that value, I plugged it in here. And you're going to take this x value and plug it into the original formula. Okay, well, I don't want to have to write that out in words, so I'm going to write it instead as f of negative b over 2a. Once you need to find that negative b over 2a value, that axis of symmetry, just take that value and plug it into your original formula. I think we might have mentioned this last class too. For the y-intercept in this equation, what is the y-intercept? Is it the a, b, or c value? It's the c value. If you plug in 0 for x, and you plug in 0 for x for the b, so let me try that again. 0 squared plus b, that's a b, times 0 plus c. These are going to cancel. These are going to cancel. So you're just left with the c. So my y-intercept, and you can do this only for standard form, is 0, c. Last question. Tristan, how do I find the roots for a standard form equation? I'll give you a hint. Look back at your notes from last class. How do you find the x-intercepts? Okay, but how do you know what to factor? Read this out.
Plug in 0 for y and solve y.
Oh, you're so thorough. I appreciate that. Yes, that's exactly it. So I'm not going to write out all of that craziness, but I am going to put plug in or substitute 0 for x. No, 0 for y. That was 0 for y, right? Yeah, plug in 0 for y. And I'm going to put and solve by any method. Now, these are my notes. I know what any method means, but if you don't know what method I'm talking about and you had to do like Tristan and read from the last page, I would probably write out solve by completing the square, factoring, square root, and quadratic formula. Actually write out those forms. This is your study cheat sheet, so that way you are ready to study for your tests and quizzes. So write it however you feel. Completing the square, factoring, square root method, and quadratic formula. Those are the any method that I was writing down. So what I'm going to do now is I'm going to give you guys about 4 or 5 minutes. I want you, this is your chance to prepare for studying for that quiz you have or test you have coming up. Look back at the notes that we've done for Intercept and Vertex form, which was all today, and I want you to fill in all of the information that you need for 1 or 2 and 3, for Intercept form and for Vertex form. I will tell you, when I kind of move on, I'm not going to fill in all of this stuff for you. This is for you to fill out to help you study. So look back at the notes, think about what we did. Max and min, you can recopy from the top. Max and min are the exact same. So feel free to use this form, this summary cheat sheet for studying, not for tests and quizzes. Feel free to use this to help you when you're studying for your tests, your quizzes. If you're coming in before a test or quiz, you can quickly glance at this to give your brain a refresher. So make sure you have it all filled in. We're going to go ahead and look at the last page, and we're going to look at questions 1 and then 1 and 2 at the bottom. So we're going to look at these 3 questions. If you think back to the notes that we did last time, we did actually go from vertex form into standard. So we went from having that parentheses squared into something that was ax squared plus bx plus c. Now that we've learned 2 additional forms, I'm going to have you guys go into 2 additional forms on your notes. So the first part says convert from standard form, which is y equals ax squared plus bx plus c, which all of these are pretty much in. And we're going to convert this into intercept form. Okay, well, intercept form, you should have just written this on your last page that we were just on. Intercept form is y equals a, x minus p, and x minus q. Chris, how am I going to get this into intercept form? What does it look like they probably did to get those 2 binomials? They factored it. That's exactly it. All we need to do for these 3 questions at the top is factor. So since you guys know how to factor and we talked about it last time, I'll just do 1 question with you, but that's all you have to do. If you see questions like this, on your homework, make sure you do the same thing. So, for example number 1, I'm going to go ahead and first, you want your x value, especially since each of the x's in here, the x minus p and the x minus q, the coefficients in front of x are positive 1s. So let's first factor out this negative to make this y equals negative 1, x squared plus 2x minus 3. When you factor out a negative, it's going to switch every single sign that's in your parentheses. Chris, is that what you meant to factor? Just factor out that negative 1? Okay, what else do I still need to do? Okay, so in here, that x squared plus 2x minus 3, I need to do that little x chart to factor it. So I have to factor the x part. So Chris, give me two numbers that multiply to negative 3 but add up to positive 2. What two numbers can I use? What two numbers can you multiply to get to 3? Negative 1, positive 3? Yeah, that'll give you 3, all right. So negative 1 times 3 will give you negative 3, and then negative 1 plus 3 will give you 2. Perfect. That's what I want. From here, I'm going to write both of my binomials. Since this leading coefficient in front of x squared is a 1, I can rewrite this as x minus 1 and x plus 3. So I kind of have everything written out. I know my a, I know my x minus p, x minus q. Let's write it as one big equation. So I'm going to write this as negative, you don't have to put the whole 1, but negative, parentheses, x minus 1, x plus 3. That would be your answer. So if I ask you to write it in intercept form, it's a fancy way of saying just factor it. At the bottom, I'm going to do question 1, you're going to do question 2, and then we're done. So at the bottom of the page, question 1, this one says convert from standard form, and you're putting it into Vertex. Standard is ax squared plus bx plus c. And we're going into Vertex form, which is a, if I could actually write this correctly, a x minus h squared plus k. So if I look at question 1, the first thing that I think of is I have no idea how I'm going to get to this form here. Okay, well, if you think back to what you should have done several weeks ago when you were looking at completing the square, which were these notes here, I gave you some steps. In those steps, I told you to rewrite, if you were solving, make the constant on the other side of your equation over here, and then you would need to divide both sides by a in case you had an a value, which in this case we don't, and then you would need to complete the square. We're going to do all of these steps, most of them, I'll say, most of these steps on the other side of the page, so the one that you guys are currently looking at, in order to solve that equation that we have and write it in its correct form for Vertex. So let me go back over here, and I'm going to go through my steps referencing the completing the square method. So over here, I'm going to zoom in a bit. Y is going to equal. We're going to have our leading coefficient here is positive 1. So that's a good thing. We're going to make this x squared plus 4x, as I did during the notes when we did completing the square. We're going to leave a space, empty space, minus 3, leave another space. Normally, all of this information would be on the other side of y, but since we're not solving the equation, we're actually trying to rewrite it in order to graph, I'm just going to keep it on this right-hand side of my equation. Once we have that, I'm going to go back to my steps here, and it says complete the square by taking half of b, squaring it, and adding it to both sides of your equation. Okay, well, I'm not going to necessarily add it to both sides of my equation, but I will add it to both of the blanks that I have. So we're going to make this 4 over 2 squared. That is your b value over 2 squared. Well, your b is 2, and 2 squared is going to give me 4. Okay, well, let's think back to what we did back in the solving by completing the square. When you guys were doing this in those notes, I told you to factor this. So since I'm pretty sure some of you guys don't remember, I told you guys to factor. We needed to find two numbers that multiplied to 4, but also added up to 4. The only combination of numbers we can use are 2 and 2. Remember, in order to write the polynomial here in factored form, you would rewrite it as x plus 2 times x plus 2. That would be the factored form for this trinomial. Well, think about it. What's another way we could rewrite this? Well, another way that we could rewrite this is x plus 2 squared. Keep in mind, guys, when you're completing the square, you don't have to do this part. I only did this because I'm pretty sure most of you guys forgot what to do. What you really should be doing is just whenever you take half of b, this number here is always going to be put in this parentheses every single time, whether it's positive or negative. And then once we finish that, we're just going to add these two terms at the end, which are negative 3 plus 4, which will give you a positive 1. This equation is now in Vertex form. You have an a value of a positive 1. Here's your h. Here's your k. That's all you have to do. So right now, I want you to pause the video and I want you to try to do example 2, referencing what we just did on example 1. So for question 2, let's go ahead and solve this. You should have had y equals x squared minus 2x, leave a space, minus 15, leave another space. We're going to take this b value, which is now negative 2, and it's okay for it to be negative. We're going to divide it by 2 and square it. Well, negative 2 squared is negative 1, or excuse me, negative 2 divided by 2 is negative 1, and negative 1 squared is just a positive 1. So in both of these empty spaces, I'm going to add a 1. Normally, if you don't remember how to do this based on the rules that we talked about in our completing the square video, you're going to have to factor this. But since I remember what I just said on the prior question, we're going to rewrite this as x minus 1 squared. I'm just recopying that x minus 1 in that parentheses. And then at the very end, I'm going to subtract negative 15 plus 1, which is going to give me negative 14. This is the easiest way to solve these questions. If you don't like doing this method, so if you don't like having to do completing the square, you can use the original equation that you have and go back to the notes that we did last class period, where you could actually go through mathematically and do these first 2 steps to find your vertex. And then once you find that vertex, you can just relabel that a value, which in this case is a positive 1, and recopy it. If you want to do that, you definitely can. But I'm telling you guys, y'all are all in Algebra 2. You should be able to get this done and get this answer. If you have any questions or if you haven't finished your study cheat sheet, now would be a good time to finish. If you have any questions, make sure you let me know.